expression for potential energy. To carry an object of mass m to a height h above the Earth's surface, a force equal to mg has to be used against the direction of gravitational force, and the amount of work done can be calculated as follows. You know that work is force multiplied by displacement. Now here, in this case, the force is mass into acceleration, but it is acceleration due to gravity, and so F is equal to mg, and displacement is you are carrying the object to a height, so height h is the displacement. So you can write W is equal to mg multiplied by h, and therefore W is equal to mgh. So the expression for potential energy is W is equal to potential energy. Of course, potential energy is also work done, and the expression is given by mgh, that is mass, acceleration due to gravity, and height. Therefore, the displacement of height h causes energy equal to mgh to be stored in the object. Now let us take up a solved example. 500 kg water is stored in the overhead tank of a 10-meter high building. Calculate the amount of potential energy stored in the water. Now let us write the given. Height is 10 meter, mass is 500 kg, acceleration due to gravity is 9.8 meter per second square, and therefore potential energy is equal to mgh, that is mass 10, acceleration due to gravity 9.8, and height is 500. Mass is 500 and height is 10. So when you multiply the 3, you get 49,000 joules. The unit for potential energy, that is the work done, is joule. Ajay and Atul have been asked to determine the potential energy of a ball of mass m kept on a table as shown in the figure. What answers will they get? Will they be different? And what do you conclude from this? Let the answer obtained by Ajay be the potential energy is equal to mgh1, that is for height 1. And the answer obtained by Atul be potential energy mgh2, that is height 2. So the height at which the ball is kept is different for both of them, and therefore the potential energy of the ball with respect to Atul and Ajay will be different because the height is different. And from this activity, what we conclude is that potential energy is relative. The heights of both the ball with respect to Ajay and Atul are different, so the potential energy with respect to them will also be different. Transformation of energy. Which are the different forms of energy? Which type of energy is used in each of the following cases? The different forms of energy are mechanical energy. As we have studied earlier, it is in two forms: potential energy and kinetic energy. And the different forms of energy are mechanical energy, electrical energy, sound energy, chemical energy, light energy, heat energy. So energy is in various different forms. Which type of energy is used in each of the following processes? Now let us see each one by one. The first one is a stretched piece of rubber. In this process, the type of energy used is potential energy. Fast moving car, the type of energy used is kinetic energy. Third, the whistling of a cooker due to steam. The type of energy used is heat energy. Fourth, the crackers exploded in Diwali. The type of energy used is chemical energy and heat energy. Fifth, a fan running on electricity. The type of energy used is electrical energy. Sixth, drawing out pieces of iron from garbage using a magnet. You can think about it. Yes, you are right. It is magnetic energy. Seventh, breaking of glass window pane because of loud noise. Here also you can guess it is sound energy. Now you can see here energy can be transformed from one type to another. For example, the exploding firecrackers convert chemical energy stored in them into light, sound, and heat energy. Observe the diagram and discuss how transformation of energy takes place, giving examples of each. You can observe electric motor converts electric energy into mechanical energy. Electric heater converts electric energy into heat energy. Steam engine converts heat energy into mechanical energy. Microphone converts sound energy into electrical energy. Loudspeaker or headphones, they convert electrical energy into sound energy. Solar cell or photoelectric cell, they convert light energy into electrical energy. Electric lamp converts electrical energy into light energy. Primary cell converts chemical energy into electrical energy. Secondary cell converts electrical energy into chemical energy. Generator converts mechanical energy into electrical energy. And lastly, thermocouple, it converts heat energy into electrical energy. Law of conservation of energy. As we have seen earlier, energy can be transformed from one type to another. So, there is a law of conservation of energy. Energy can neither be created nor destroyed. It can be converted from one form to another, and thus the total amount of energy in the universe remains constant. Okay, so energy can only be converted or transformed from one form to another, but the total amount of energy in the universe remains constant. Try this. Take two pendulums of the same length with the help of thread and two nuts. Tie another thread in the horizontal position. Tie the two pendulums to this horizontal thread in such a way that they will not hit each other while swinging. Now swing one of the pendulums and observe. What do you see? What we observe is initially when both the pendulums are still, they have potential energy stored in them. When one of the pendulum is set into motion, its potential energy gets converted into kinetic energy and the pendulum starts swinging. After a while, this kinetic energy gets transferred to the second pendulum. The speed of the oscillation of the first pendulum slowly decreases and the second pendulum, which was initially stationary, begins to swing. In this way, energy from first pendulum is transferred to the second pendulum. If you just hit the nut, that is of the first pendulum, it will start moving and it will gain kinetic energy. At one point of time, it will hit the second pendulum, which is stationary, which has got potential energy. As soon as the first one hits the second, its potential energy gets converted to kinetic energy and it starts moving, and the first pendulum, it loses energy and it slows down. So energy is transferred from the first pendulum to second pendulum. Thank you.